Concept 3 question D is going to ask us about an actual scenario in which we'll have to use the graph of an absolute value function. Here we're looking at, in the graph, an aerial view of a miniature golf setup. So the ball, which is labeled, is definitely blocked by an obstacle. You can see that the obstacle is preventing a straight path from the ball straight to the hole, which is marked with this dark circle, so that the only option for this person, if they wish to make the shot, is to use a bank shot off of the wall that you see marked up top. Now, a bank shot would create a sort of V shape, resembling that absolute value that you were dealing with in question C. So if you recall, the absolute value is kind of a V shape. So the bank must have to start from where the ball is, hit the wall, and go straight into the hole. The important thing to remember, and I drew a pretty terrible diagram here, is that if you bank it at a certain angle, it's going to bounce off at the exact same angle. So we need to pay particular attention to the slope from the ball up to the bank point, because it's going to have to be the exact same slope when it goes to the hole. So let's look at our graph and let's see if we can make some sense of this. The coordinates of the golf ball are 3, 1, that's already done for us. And it's telling us that the coordinates of the hole are at 9, 2, done for us. The obstacle, which is the part in the way, forces us to bank the ball at 5, 9. So let's quickly look. That's 5, 9, which is here. So I'm going to mark the coordinates there, remembering that if we revisit our potential diagram here, that point should end up being the vertex point of our absolute value. So let's assume, for the sake of argument here, that 5, 9 is the point that we're actually going to need in our equation, because that's our vertex. So we know for sure that in question number 1, asking us for the absolute value equation, when it comes to writing something inside those bars, we're going to use x minus 5, remembering that the inside of the bars always changes signs, plus 9, remembering that that y coordinate, the k value, stays the same. The only thing we haven't paid attention to is that a value, that value in the front that we need to pay attention to. Because the bank shot's going to need to happen, we are going to eventually be looking at a V shape that would clearly be facing upside down. So there must be a negative in front of that A value. To connect and really get that A value, we're going to use a strategy we used in a prior question, which is to just count. If you count from the ball, rise over run, to get to the wall, we're just going to count those units, and we're simply going to translate that into a fraction. So let's count from here. That's 1, 2, 3, 4, 5, 6, 7, 8 for our rise, over 1, 2 for our run. 8 over 2 would be 4, so we know that our A value is 4. Again, it's going to be negative 4 because that A value needs to be negative to show that we're going to be upside down. Now, we can connect the dots if we'd like, but we need to remember something important, that if our rise over run was 8 over 2, that means it's going to have to be the same in the other direction as well, which is really going to help us predict what's going to happen when the ball bounces from the wall and tries to go into the hole. So let's start at the wall and let's do the exact same thing. Let's count our rise of 8. This time I'm going down, but it works the same. Our run of 2. You can see that this bank shot is not going to land us where we need it to go. If I do the exact same rise over run, 8 over 2, that rise over run is not going to put us in the right position. It's actually going to fall too short, and we will not make the shot. So in question 2, if Walt hits the ball perfectly, will he make the shot? We can see that he won't. He can hit the ball perfectly to hit the wall at the exact point that he wants to hit, but the absolute value means that it's going to bounce off with the exact same slope, the same angle, and it's not going to end up working out. In fact, it'll hit the obstacle before it even goes near the hole. So we would say no, and there are a variety of different ways you can explain that answer. The easiest way is to probably show the graph and to just show that the point that you get by bouncing off the wall and landing in the exact same spot on the other side is clearly 2 full units away from the hole, so he will not make it.